Hi, today we're looking at section 2.6 on scatter plots. Our question is, how can you tell if a set of data points can be modeled by a line? And if so, how do you determine the equation of the line? So before we get into problems, let's look in the text here on the first part of the section, a couple vocabulary terms. It says here, a scatter plot is a graph of a set of data pairs. So it's just basically data XY coordinates. So we also have the difference between a positive correlation and a negative correlation. So if y increases as x increases, the data has a positive correlation. You can see in this first one here, as my x values increase, my y values increase. The data has a positive correlation. Negative correlation, as my x values increase, my y values decrease. And then this one shows approximately no correlation, because you can't tell as x increases whether y is increasing or decreasing. It's rather scattered. Okay, so the first example in the textbook, we can look at that right here, asks you to describe the correlation shown by the scatter plot. So this first one, as x is increasing, y is increasing, so this would be a positive correlation. However, this one would be a negative correlation. As x increase, y is decreasing. So that's pretty simple. The next page, the top, talks about a correlation coefficient, denoted by R. It's a number from -1 to 1 that measures how well a line fits a set of data. As it nears 1, it's close to a line with a positive slope, and as it approaches -1, it's a line that lies close to a line with a negative slope. If it's 0, that would indicate no correlation. So if you look at this example here, this first one, you can see that the data is decreasing. As x increases, y is decreasing. If I was to draw a line in the middle here, I could do that, but the data points are not exactly close to that line. So it would be a negative correlation, but it wouldn't be -1 because the points are not near the line. So I would give that a correlation coefficient of -0.5. This one here, the data points are scattered. You wouldn't really be able to draw a line of best fit, which we'll talk about later, a line that fits the data here. So the correlation coefficient would be 0. This one here, the third one, I could draw a line that closely goes through the middle of those points. So therefore, this would have a correlation coefficient of 1. Okay? So let's go down to the guided practice on the bottom and see if you can decide what you would give as a correlation coefficient for these three. Would it be -1, -1/2, 0, 1/2, or 1? So pause the video, give it a shot, and then start the video again. Okay, so this first one, if I was to draw it, you can see it's a positive correlation. If I was to draw a line through here, the data would not be completely near that line, so I'd give that one a +1/2 as a correlation coefficient. Now remember, this is not a slope, okay? It's just a value, a number that indicates how close your data is to the line. This one here decreases, so it's a negative correlation coefficient, but it's close to a line, so this would be -1 for that one. This one would be 0. Okay? Next page. Approximating a best fitting line. Okay, once we have data, we want to approximate a best fitting line, a line that best goes through that data. So here are the steps. Draw a scatter plot of the data. Sketch a line that best fits through that data. It says there should be about as many points above the line as below it. Choose 2 points on the line and estimate the coordinates of each point. Find the slope and write the equation of the line based on that and the y-intercept. Okay, so I'm going to use some data, get some graph paper out here. Okay. Okay, so we are going to graph here. This table will show the blood pressure of patients, so based on their age. Let me write it down here. Okay, so here's the data. We want to graph that data and come up with the equation of the line. So I'm going to have to zoom out a little bit. Okay, so let's draw XY axis. Well, the first thing I look at is the fact that my data has some bigger numbers, so I got to think about scaling. So I'm going to scale the x-axis maybe by 5s. And now because my first number, well, I'll start at 0 here. So am I going to get up to 70? That would be 14. So let's try that. 5, 10. 50. And my y-axis goes all the way up to 150, so maybe I got to go by 10s there. 10, 50, 90, 100, 150, and 70 or so. Okay, so let's plot those points. So 43, 128. Right about there. 48 is 120. 56 is 135. 135 right there. That's 56. So we'll slide that over just a little bit. 61 is 143. 67 is 141. And 70 is 152. Okay, so there's my data. If I was to give that a correlation coefficient, I would say it'd probably be +1. Okay. So the next step is to try to estimate a line that goes through that data. So I'm going to do that. So there's my line. So our equation is in the form of y equals mx plus b, so we need a slope and a y-intercept. Okay, so to find the slope, I find 2 points on this line that ideally go through a grid on the graph paper and make it easy. Okay, so there's a point. And let's just use this point right there. Oops. And then we make our slope triangle. Now be careful with your scale, because I went up by 10s here, so that's 10, 20, 30, 40. And I went up by 5s here, so 5, 10, 15, 20, 35. So my slope looks like it's 40 over 35, which simplifies down to 8 over 7. My y-intercept, so let's look at that. That looks like 50, 67, 68. Let's call that 68. Actually, we're by 10, we're by 5. So 50, 60, 70. This would be 80, so it would be maybe about 78 or so. Let's call it 78. So y equals 8 over 7x plus 78. would be the equation of this data. Now, is that the exact equation that works for this? Well, it's just an estimate. Now, what can we use this data for? Let's just say I wanted to know what the blood pressure is of somebody who's 80. I could just plug that into the equation and come up with an answer. Now in class, what I will show you is how to use your graphing calculator to plug this information in and come up with the exact equation and see how close we are to this actual equation. So that's it for section 2.6. Thank you.